Welcome all students. Today we are going to continue our discussion of Unit 1 and the topic is networks, internet and protocols. In this session we are broadly discuss the types of the networks, internet and its history and protocol and standards. So first of all, categories of network. Some of terms you may familiar with, just like a LAN, WAN and MAN. So we can discuss over here. Today when we speak of networks, we are generally referring to two primary categories: local area networks and wide area networks. The category into which a network falls is determined by its size. A LAN is normally covers an area less than 2 miles. A WAN can be worldwide. Networks of the size in the between are normally referred to as a metropolitan area networks and span tens of miles. Means MAN is a category between LAN and WAN. So over here the brief introduction of LAN, WAN and MAN written over there. LAN means short distance, WAN means long distance and metropolitan means a particular city area. Starting with LAN. A local area network is usually privately owned and links the device in a single office, building or campus, as shown in this figure. Over here 12 computers are connected with a hub. Depending on the needs of the organization and the type of the technology used, a LAN can be as simple as 2 PCs and a printer in someone's office, or it can be extended throughout a company and include audio and video peripherals. Currently, LAN sign is limited to the few kilometers only. A LAN are designed to allow resources to be shared between personal computers or workstations. The resources to be shared can be include hardware, just like a printer, software, just like an application program, or a data. A common example of LAN found in the many business environment links a work group of a task-related computers, for example, engineering workstation or accounting PCs. One of the computers may be given a large capacity disk drive and many may become a server to the client. Software can be stored on this central server and used as needed by the whole group. In this example, the size of the LAN may be determined by licensing restriction on the number of users per copy of a software, or by the restriction on the number of the users licensed to access the operating system. In addition to the size, LAN are distinguished from the other types of networks by their transmission media and topology. In general, a given LAN will be use only one type of a transmission medium. The most common LAN topologies are bus, ring and star. As we already discussed in the previous session, different types of topologies. Early LANs had a data rates in 4 to 16 megabytes per second or Mbps range. Today, however, the speed are normally 100 or 1000 Mbps and beyond. Wireless LANs are the newest evolution in the LAN technology, as we can see in our home, just like a router. Next is wide area network. A wide area network or WAN provides a long distance transmission of data, image, audio and video information over the large geographical areas that may be comprise a country or a continent or even the whole world. A WAN can be complex as a backbones that connect the internet, or it as simple as dial-up line that connects at home computer to the internet. We normally refer to the first as a switch WAN and the second one to the point-to-point WAN. As we see in this figure, The switch WAN connects the end system, which usually comprise a router, internet working, connecting devices that connects to the another LAN or WAN. The point-to-point WAN is normally a line leased from the telephone or cable TV provider that connects a home computer or a small LAN to the internet service provider ISP. This type of WAN is often used to provide internet access. As we can see in this figure, there are two figures mentioned, a switched WAN and point-to-point WAN. In the first switched WAN, three end systems are connected with the switched WAN. A particular yellow box shows the switch diagram or switch symbol. In the second point-to-point WAN, a particular modem is connected with the computer or ISP. The modem is mainly responsible to transmission of data and receiving of data. The each and every component of this diagram, just like a modem, WAN, switched WAN, switch, etc., we are also going to see in the further sessions. An early example of a switched WAN is X.25, a network designed to provide a connectivity between end users. We also going to see in detail in the further chapter. X.25 is being gradually replaced by the high-speed, more efficient network called frame relay. A good example of a switched WAN is a asynchronous transfer mode ATM network, which is a network with fixed site data unit packets called cells. We also going to see this topic further in next sessions. Last, MAN. MAN means Metropolitan Area Networks. A Metropolitan Area Networks is a network with a size between LAN and a WAN. It normally covers the area inside a town or a city. It is designed for a customer who need a high-speed connectivity normally to the internet and have endpoints spread over a city or a part of the city. A good example of MAN is a part of a telephone company network that can provide a high-speed DSL line to the customer or subscriber. Another example of this is a cable TV network that originally was designed for a cable TV, but today can also be used for a high-speed data connection to the internet. As we can see, our some network provider also giving a service of internet, just like Airtel. Now, if we connect different network to each other, what it forms? The interconnection of network is called as a internet work or internet work. Today, it is very rare to see LAN, MAN and WAN in isolation. They are connected to each other. When two or more networks are connected, they become an internetwork or internet. And as an example, assume that our organization has two offices, one on the east coast and the another is a west coast. The established office on the west coast has a bus topology LAN, and the newly opened office on the east coast has a star topology LAN. The president of the company lives somewhere in the middle and needs to have a control over the company from her home. To create a backbone WAN for connecting these three entities, two LANs and a president's computer, a switched WAN operated by the service provider such as a telecom company has been leased. To connect LAN to this switched WAN, however, 3 point-to-point WAN are required. This point-to-point WAN can be high-speed DSL line offered by the telephone company or a cable modem line offered by the cable TV provider as shown in this figure. Over here, three entities are there: our president's computer, our one LAN and our second LAN. our LAN are connected with the router. Router is also connected to the point-to-point WAN, and this is our switched WAN. This is our switched WAN. This switched WAN is connected to the our point-to-point router, and that is connected to our main router, which are connected with our hub. In the other hand, a modem is connected to our switched WAN. That modem is connected to our president's PC. So you can see it is an interconnection of different network categories. So one of the important thing in your exam as well as in your real life scenario. So what is the difference between LAN, MAN and WAN? In this slide, the main difference between LAN, MAN and WAN are written over there. First is, in the LAN, connection is a small and physical area. Small physical area. In the MAN, it is a some larger geographical area than LAN. And in the WAN, it is the largest distance, just like our world. Second difference is the best LAN type used with the Ethernet. The Ethernet is used in a mainly LAN. In the MAN, used with the Internet and Ethernet. In a WAN, it used with Internet. Third, LAN is a faster than WAN. MAN have such a higher speed, and WAN have a less speed than LAN. Fourth difference, LAN is cheaper, whereas MAN is a competitive price, and in a WAN it is more expensive. Fifth, LAN requires more likely to need a password validation as it have a specific user rights. In a MAN needs password validation as it will have a specific user rights, just like a LAN. In a WAN, have a less likely need a password validation as it have a specific user rights. Sixth difference, LAN is a more private. In a MAN, it have a higher security. In a WAN, have a less private. Seventh difference, in the LAN, hardware focus on a sharing of resources. In the MAN, hardware focus on the data transmission. In a WAN, hardware focus on the communication. Last difference, LAN operates on a peer-to-peer. In a MAN operates by a organization and a public utilities. In a WAN operates on a client-to-server model. So it is a brief idea about the comparison of LAN, MAN and WAN. It is the most important question for your GTU. So read it carefully and understand it. Now we can move ahead. What is the internet? The internet has revolutionized many aspects of our daily lives. It has affected the way we do business as well as the way we spend our leisure time. Count the way you have used the internet recently. Most of the student or most of the people in the recent area are familiar with internet and are used to internet. Without internet, you cannot imagine the recent life. So internet is our part of the life. Perhaps you have sent electronic mail to a business associate, paid a utility bill, read a newspaper from the distant city, looked up a local movie schedule, all by using the internet. Or maybe you researched a medical topic, booked a hotel reservation, chatted with a fellow ticket, or a comparison shopped for a car. The internet is a communication system that has brought a wealth of information to our fingertips and organized our use. The internet is structured, organized system. We begin with a brief history of the internet. We follow with a description of the internet today. A network is a group of connected communicating devices such as a computer and a printers. The internet is a two or more networks that can communicate with each other. The most notable internet is called as a internet. A collaboration in the more than hundreds of thousands of interconnected networks. Private individuals as well as various organizations such as government agencies, schools, research facilities, corporations and the libraries is more than 100 countries use the internet. Millions of the people are users. Yet it is extraordinary communication system only come into being begin with and just like a 1969. In the mid of 1960s, mainframe computers in the research organization were standalone devices. Computers from the different manufacturers were unable to communicate with one another. The Advanced Research Project Agency called as ARPA in the Department of Defense was interested in finding a way to connect computers so that the researchers they founded could share their findings, thereby reducing the cost and eliminating the duplication of effort. In 1967, at an association for a computing machinery meeting, ARPA presented its idea for ARPANET, a small network of connected computers. The idea was that each host computer, not necessarily from the same manufacturer, would be attached to the specific or specialized computer called as a interface message processor. The IMP in turn would be connected to the one another. Each IMP had to be able to communicate with the other IPs as well as its own attached host. By 1969, ARPANET was a reality. 4 nodes at the University of California at Los Angeles, University of California at Santa Barbara, and Stanford Research Institute and the University of Utah were connected via IMPs to the form of network. Software called Network Control Protocol (NCP) provided communication between the hosts. In 1972, Vint Kraft and Bob Kahn, both of whom were part of the core ARPANET group, collaborated on what they called Interneting Project. Kraft and Kahn landmark 1973 paper outlined the protocols to achieve end-to-end delivery of packets. This paper on the Transmission Control Protocol (TCP) include concepts such as encapsulation, the datagram, and the function of gateway. We are also going to see each and every term in detail in the further sessions. Shortly thereafter, the authorities made a decision to split TCP into 2 protocols: Transmission Control Protocol (TCP) and Internetworking Protocol (IP). IP would handle datagram routing, while TCP would be responsible for high-level functions such as segmentation, reassembly, and the error detection. The Internetworking Protocol becomes known as a TCP/IP. Okay, this type of internet history we have seen. We can also go through the history of internet with a very good video I found in the internet or YouTube. Let's look.
The Internet in the year 2009. We send emails, make calls over the Internet, and discuss topics we take an interest in. Even our banking is going virtual. But what we take for granted today was only a vague idea 50 years ago. In order to understand how we got this far, let's go back to 1957, when everything began. Before 1957, computers only worked on one task at a time. This is called batch processing. Of course, this was quite ineffective. With computers getting bigger and bigger, they had to be stored in special cooled rooms. But then the developers couldn't work directly on the computers anymore. Specialists had to be called in to connect them. Programming at that time meant a lot of manual work, and the indirect connection to the computers led to a lot of bugs, wasting time and fraying the developers' nerves. The year 1957 marked a big change. A remote connection had to be installed so that the developers could work directly on the computers. At the same time, the idea of time sharing came up. This is the first concept in computer technology to share the processing power of one computer with multiple users. On October 4th in 1957, during the Cold War, the first unmanned satellite Sputnik 1 was sent into orbit by the Soviet Union. The fear of a missile gap emerged. In order to secure America's lead in technology, the US founded the Defense Advanced Research Project Agency in February 1958. At that time, knowledge was only transferred by people. The DARPA planned a large-scale computer network in order to accelerate knowledge transfer and avoid the doubling up of already existing research. This network would become the ARPANET. Furthermore, 3 other concepts were to be developed, which are fundamental for the history of the Internet. The concept of a military network by the RAND Corporation in America. The commercial network of the National Physical Laboratory in England. And the scientific network Cyclades in France. The scientific, military, and commercial approaches of these concepts are the foundations for our modern Internet. Let's begin with the ARPANET, the most familiar of these networks. Its development began in 1966. Universities were generally quite cautious about sharing their computers. Therefore, small computers were put in front of the mainframe. This computer, the interface message processor, took over control of the network activities, while the mainframe was only in charge of the initialization of programs and data files. At the same time, the IMP also served as interface for the mainframe. Since only the IMPs were interconnected in a network, this was also called IMP subnet. For the first connections between the computers, the Network Working Group developed the Network Control Protocol. Later on, the NCP was replaced by the more efficient Transmission Control Protocol. The specific feature of the TCP is the verification of the file transfer. Let's take a short detour to England. Since the NPL network was designed on a commercial basis, a lot of users and file transfer were expected. In order to avoid congestion of the lines, the sent files were divided into smaller packets, which were put together again at the receiver. Packet switching was born. In 1962, American Ferret aircraft discovered middle and long-range missiles in Cuba, which were able to reach the United States. This stoked fear of an atomic conflict. At that time, information systems had a centralized network architecture. To avoid breakdown during an attack, a decentralized network architecture had to be developed, which, in case of loss of a node, would still be operative. Communication still used to work through radio waves. That would have caused problems in case of an atomic attack. The ionosphere would be affected and the long-wave radio waves wouldn't work anymore. Therefore, they had to use direct waves, which, however, don't have a long range. A better solution was the model of a distributed network. Thus, long distances could be covered with a minimum of interference. Another milestone followed with the development of the French network Cyclades. Since Cyclades had a far smaller budget than ARPANET, and thus also fewer nodes, the focus was laid on the communication with other networks. In this way, the term Internet was born. Moreover, Sukladi's concept went further than ARPA's and the MPL's. During communication between sender and receiver, the computers were not to intervene anymore, but simply serve as a transfer node. Sukladi's protocol went through all machines using a physical layer that was implemented into the hardware, providing a direct connection with the receiver, an end-to-end structure. Inspired by the Sukladi's network and driven by the incompatibility between the networks, their connection gained in importance everywhere. The phone companies developed the X.25 protocol, which enabled communication through their servers, in exchange for a monthly basic charge, of course. DARPA's transmission control protocol was to connect the computers through gateways. And the International Organization for Standardization designed the OSI reference model. The innovation of OSI was the attempt to standardize the network from its ends and the channel's division into separate layers. Finally, the TCP assimilated the preferences of the OSI reference model and gave way to the TCP/IP protocol, a standard which guaranteed compatibility between networks and finally merged them, creating the Internet. By February 28, 1990, the ARPANET hardware was removed, but the Internet was up and running.
So, you have seen a very good animation of a history of Internet. I think it is very useful to you. Let's move ahead. So, what the Internet today? The Internet has come a long way since 1960s. The Internet today is not a simple hierarchical structure. It is made up of many wide and local area networks joined by connecting devices and switching stations. It is difficult to give an accurate representation of Internet because it is continually changing. The new network are being added. Existing network are to be adding addresses, and the networks of different companies are being removed. Today, most end user who want internet connection use the service of a internet service provider, or called as a ISP. There are international service provider, national service provider, regional service provider, and the local service providers. Internet today is run by a private companies, not the government. A given figure shows the conceptual, not a geographical view of the internet. Over here, we can see in the first upper diagram the structure of the national ISP. In the national ISP, starting with our local service provider or local internet service provider ISP. Just like suppose we can take the example of our city. It is ISP for our city. Now the upper ISP is a regional ISP, just like our state. Fine. So it is our just like a state ISP. Now upper, it is a national ISP, just like our India. If we take example by the name, so it is our India, it is our Gujarat, it is our Gandhinagar. Fine. In the second figure, the interconnection of national ISP, just like a different countries are connected with each other with a NAP. Just like India, Pakistan, China, USA, Russia. Fine. So it is just a diagram to understand the hierarchical order of the internet or organization of internet. Let's have a look. The international internet service provider at the top of the hierarchy are the international service provider that connect the nations together. The national internet service provider are the backbone networks created and maintained by the specialized companies. There are many national ISPs operating in our India or in our Gujarat, just like a GTPL, Airtel, Vodafone, etc. etc. To provide connectivity between the end user, these backbone networks are connected by the complex switching station, normally run by the third party, called as a network access point or NAP. Some national ISP networks are also connected to one another by private switching station called as a peering points. These normally operate at a higher data rate up to 600 Mbps. Now, regional internet service provider. The regional internet service provider or a regional ISPs are a smaller ISPs that are connected to one or more national ISPs. They are at the third level of the hierarchy with a smaller data rate. Last, local internet service provider. They provide direct service to the end user. The local ISPs can be connected to the regional ISPs or directly to the national ISPs. Most end users are connected to the local ISPs. Note that in this sense, the local ISPs can be a company that just provide the internet services, a corporation with a network that supplies services to its own employees, or a non-profit organization such as a college or universities that runs its own network. Each of these local ISPs can be connected to the regional or a national service provider. Next is protocol. In this session, we are also going to see the protocols and the standards. First, we define protocol, which is a synonymous of a rule, and then we discuss the standards, which are agreed upon the rules. So, what is protocol? In the computer network, communication occurs between entities in a different system. An entity is anything capable of sending or receiving information. However, the two entities cannot simply send bit streams to each other and accept to the understood. For a communication to occur, the entity must agree on a protocol. The protocol is a set of rules that govern the data communication. A protocol defines what is communicated, how it is communicated, and when it is communicated. The key elements of the protocols are syntax, semantics, and timing. We are also going to see in detail. So protocol is one type of a language. Just like a two-person understand English very well, so they can communicate easily. But if one person knows only English and if one person knows only Hindi, so they cannot communicate with each other, or it is very difficult to communicate with each other. Fine. So it is very easy to understand the protocols. Now let's see what is syntax, semantics, and timing. Syntax. The term syntax refers to the structure of or a format of the data, meaning the order in which they are represented. For example, a simple protocol might be expect the first 8 bit of the data to be the address of the sender, and the next 8 bit to be address of the receiver, and the rest of the stream to be message itself. Means it is just like a structure. Second is semantics. The word semantics refers to the meaning of each station of bits or each section of the bits. However, it is particular pattern to be interpreted and what actions to be taken based on the interpretation. For example, does an address identify the route to the taken or the final destination of the message? Last is timing. The term timing refers to two characteristics: when data to be sent and how fast they can send. For example, if a sender produces the data at 100 Mbps but the receiver cannot process the data at only, or it can only process only 1 Mbps, the transmitter will overload the receiver and some data will be lost. So timing is very important. So this slide shows the brief elements of a protocol: syntax, semantics and timing, which is very important for your exam and for your any understanding concept for our networking. Let's move ahead. Standards. Standards are essential in creating and maintaining an open and competitive market for equipment manufacturer and in guaranteeing national and international interoperability of the data and the communications technology and processes. Standards provide guidelines to manufacturers, vendors, government agencies and other service providers to ensure the kind of interconnectivity necessary in today's marketplace and in the international communications. Data communication standards fall into two categories: de facto and de jure. We are going to see in this topic few points are discussed, just like standards, standard organizations, forums, regulatory agencies and internet standards. In the category of the standards, there are two: de facto, meaning by fact or by convention, and de jure, meaning by law or by regulation. So first, de facto: standards that have not been approved by organization body but have been adopted as a standard through widespread use are the de facto standards. The de facto standards are often established originally by manufacturers who seek to define the functionality of the new product or a technology. Second, de jure: those standards that have been legalized by the officially recognized body are the de jure standards. Now let's have a look some standard organization. Standards are developed through a cooperation of standard creation committees, forums and government regulatory agencies. So some of standard creation committees, just like ISO, ITUT, ANCI or NSI, IEEE, EIA. First, ISO. The ISO is a multinational body whose membership is drawn mainly from the standard creation committees of various governments throughout the world. The ISO is active in developing a cooperation in the realms of scientific, technological and economical activity. ITUT. The full form is International Telecommunication Union Telecommunication Standards Sector. By the early 1970s, a number of countries were defining the national standards for telecommunication, but there was still a little international compatibility. The United Nations responded by the forming, as a part of its International Telecommunication Union (ITU), a committee, the Consultative Committee for International Telegraphy and Telephony (CCITT). This committee was devoted to research and established the standard for the telecommunications in the general and for the phone and the data systems in the particular. On the March 1st, 1993, the name of this committee was changed to International Telecommunication Union Telecommunication Standards Sector, like ITUT. Next is ANSI. It is an acronym for American National Standards Institutes. Despite its name, the American National Standard Institute, it is a completely private, non-profit corporation, non-affiliated with US federal government. However, all ANSI activities are undertaken with the welfare of the United States and its citizen occupying primary importance. Next is IEEE. It is an Institute of Electrical and Electronics Engineers. The Institute of Electrical and Electronics Engineers is the largest professional engineering society in the world. International is in a scope. It aims to advance theory, creativity, and product quality in the fields of electrical engineering, electronics, and the radio, as well as in all related branches of engineering. As one of its goals, the IEEE oversees the development and adoption of international standard for computing and communications. Last, EIA. It is Electronic Industries Association. Allied with NC, Electronic Industry Association is non-profit organization devoted to the promotion of electronics manufacturing concerns. Its activities include public awareness, education, and lobbying efforts in the addition to the standard development. In the field of information technology, the EIA has made significant contribution by defining physical connection interface and electronic signaling specification for the data communication. So all the organizations are very important. They have played very good role in our data communication networking development and establishment. Next is forum or forums. Telecommunication technology development is moving faster than the ability of the standards committee to ratify standards. Standards committees are procedural bodies and by name slow moving. To accommodate the need for the working models and agreements and to facilitate the standard process, many special interested or many highly group have developed forums made up of representative from interested corporations. The forums work in universities and users to test, evaluate, and standardize new technologies. By concentrating their efforts on the particular technology, the forums are able to speed up acceptance and the use of this technology in the telecommunication community. The forum present their conclusions to the standard bodies. Next is, what is regulatory agencies? All communication technologies in the subject to regulation by the government agencies such as the Federal Communication Commission FCC in the United States. The purpose of this agency to protect the public interest by regulating radio, television, and wire or cable communications. The FCC has authority over interstate or intrastate or international commerce as it relates to the communication. Last, Internet standards. The Internet standard is a throughoutly tested specification that is useful to adhere by those who work in the Internet or with the Internet. It is a formalized regulation that must be followed. There is a strict procedure by which a specific or specification attain Internet standard status. The specification begins an Internet draft. An Internet draft is working document, work in a progress into no official status, and the 6-month lifetime. Upon the recommendation from the Internet authorities, a draft may be published as a request for a comment or RFC. Each RFC is edited, assigned a number, and made available to all interested parties. RFC go through maturity levels and are categorized according to their requirement level. So it is just a stage of an Internet standard, how particular rule became a standard. Fine. So it is very easy to understand. Over here we have complete topic number 1.2, network internet protocols. Question is given to you. You have to write each and every answer in your notebook and send it to me by a given instructions. Thank you, students. See you soon or see you in next lecture.